What we have today, inshallah, we'll end the feedback and then we'll start the filters, inshallah. So as you have seen for our discussion of the all topologies of the feedback, this is a general summary how you can solve a feedback problem. So first you need to check a shabab and make sure this is a negative feedback, not a positive feedback. So we need to check the feedback polarity and we know how to do that. Okay, basically we are looking for the feedback loop and we are checking the phase of the output voltage or the test voltage, let's say, which is delta V, and going around the loop. And then if you are sure that this is a negative feedback, we need to identify the topology. We have 4 topologies, and of course the effect of these topologies only will be on the input and the output impedances. But for the gain, for all topologies, it will be reduced if you are applying a negative feedback, and the bandwidth will be extended. Okay. The second step, if you need to break the system now into 2 circuits, the beta circuit and the A circuit. And if you are able to do so, you can find the beta, you can find R11 and R22, which are the loading effects or the impedances coming from the beta or the feedback network. Then you can go ahead and find the A or the open loop gain, including R11 and R22. If it is, stated that you need to make it ideal feedback, so you don't need to go to do the R11 and R22. And at the end, you can apply all it. Any question regarding the feedback, how we can solve these problems, any difficulties, let me know so we can check them back. If not, I will proceed. So,
Doctor, I have one question.
Yes.
When there is a question that says a circuit, a feedback circuit, and it didn't identify whether it's ideal or practical, how can I, or what do I assume?
So the default is practical.
Practical.
The default is practical. It is a special case. The ideal, it is a special case. Okay. Right. So now let's talk about the stability issue of the feedback systems. We mentioned previously that all feedback or all negative feedback systems are stable, or we are applying a negative feedback. هذا اللي هو main idea. If we apply a negative feedback system, we most likely we are getting a stable system, and then also we are doing improvement for linearity, for the bandwidth and other stuff. But what do you think of this statement? Is it true for all cases? I mean, can we have all negative feedback system to be unconditionally stable? يعني دائما وابدا stable without any condition? What do you think, Shabab, of this general statement? Is it true or not?
I don't think it's true.
Not true.
ليش تتوقع انه it's not true?
It's not necessarily always going to be stable.
Okay.
Always.
Okay, so what do we know about what do we know about the pole? If you have a pole in a system, what is the phase introduced by that pole? I mean, usually, so we'll introduce a phase shift of how much? Each pole?
Minus 90.
Minus 90, exactly. So imagine a system. If you have a system, this is your A. Okay, and this is my beta. And of course, I'm feeding it in a negative feedback topology. Okay, so this is a negative feedback, and I'm expecting AF to be what? A over 1 plus beta A. تمام؟ خلاص يا شباب, this is a closed loop feedback with a negative feedback implemented. But now imagine you have in this system, you have more than 2 poles, or let's say 3 poles. Okay, so instead of using, I mean, this is it is implemented, it is connected in negative feedback, but because you have 3 poles in the system, and now I'm looking to the system in general, I have 3 different poles, and each one will introduce a minus 90 degrees phase shift. Okay, so this negative feedback at some point, and now we have the option, because this is versus frequency, صح? The phases, the phase change with the frequency. It depends on the frequency. If you are applying a low frequency or high frequency, it depends on the phase, on the frequency you're applying. So imagine, of course, we have a range from 0 to minus 270 here, 270. So imagine a case where you hit, and I cannot change the colors here, I don't know why. If you can find an omega, which is a specific frequency, that will give you a minus 180 degrees in the phase or in the loop. Tamam? So this one will give you minus 180 degrees in the loop, and you add that to the negative feedback. So effectively, what you have يا شباب, minus 180 من هنا وماينس 180 من السيستم نفسه, كم عندنا؟
minus 36.
Exactly. So what is the polarity of the feedback now?
The same. Positive.
It is?
Positive feedback.
ما أسمع.
Positive.
It is positive feedback, صح? So you are changing the negative feedback into positive feedback. But is it the same situation if you have a single pole? What do you think if you have a single pole? Will we have this situation?
No, it's be negative.
No. So in the single pole systems, a feedback single pole system, we have unconditional stable system. This is true statement. Okay. So if you have one pole, this is unconditional stable system. What about 2 poles, Shabab? What do you think if you have 2 poles now?
Stable.
كيف?
Stable.
It is stable, right? Because it can be minus 360, but this will happen at the frequencies like infinite frequencies. يعني with the 2 poles, you can hit the minus 360 degrees, which is 360, which is 0, which is a positive feedback, but that will be at omega almost at infinity. Okay, so we don't care about this one. So even with 2 poles, we are still in good shape. So the only condition here to have unconditional stable, to have 1 or 2 poles in the system. Okay, and you need to make sure you are not getting to the minus 180. So if you have 3 poles or more, you need to be very, very careful, because at the end of the day, you may introduce a minus 180 phase shift, including your minus 180 coming from the feedback system, and then your system will be unstable. I'll give you here an example. طبعا شباب, by the way, is it bad or good to have a stable system in general? Let us take this statement in general.
It is good.
It is good to have a stable system. Okay, if you are, let me add some specification to that. If you are using an amplifier, what about an oscillator? So usually in oscillators, what is the oscillator? The oscillator, it is what? It is what? It is a circuit that gives you an output voltage with almost 0 input voltage. Tamam? So it is an unstable circuit, and from the name, it is oscillating circuit. Okay. So because we have unstable system, or we have a positive feedback, now we can get an oscillator. So the oscillator, or the positive feedback, or the instability in the system, it is very, very nice and very good to have if you want to apply oscillators. And we'll study that in the 5th topic of the EE303. But in general, if you have filters, if you have amplifiers, if you have a general feedback system, not an oscillator, we are targeting a stable. We are targeting a stable system. So now imagine you have this system. Okay, we have this one here, and from the connection, we see this is what, Shabab? This is feedback?
This is negative.
Negative feedback, exactly. So imagine I add an RC circuit as such. So this is an RC circuit here. So this one will add a minus 90 degrees in the phase shift somehow. And you will have another minus 180 degrees phase shift somehow. If you connect this one here, will the system be stable or unstable?
Unstable.
90 and 90, these are two poles. So we have two poles here, right? So with two poles, we said, yes, you may do or you may get to the instability if you are applying an infinite frequency, right? If you have omega goes to infinity, that's a very, very, very high frequency, you may reach to that point. But it's not usually the case. So even with two poles, Shabab, systems with one pole or two poles, they are stable systems and we are still in negative feedback. So to get what? To get a positive feedback circuit, this is the one that we should consider. So we should add another RC circuit that gives us minus 270. And by selecting the specific frequency, we can apply the positive feedback and we can get an oscillator. Okay. So although we have seemingly like a negative feedback system, we have three different RC circuits that provide minus 90 degrees each, or almost, and from 0 to minus 90 degrees each. You may end up having a positive feedback circuit. So keep in mind, Shabab, this is a true statement that all negative feedback systems are conditionally stable if they have one or two poles. But if you have three poles or more, they may end up by changing the polarity to positive and the system will be unstable. Okay? Let me also discuss here the idea of the Miller capacitor. طيب الآن يا شباب, let's take this one. This is an amplifier, right? This is an op-amp. This is what? What do you think? What is this one, شباب? Q1, Q2, Q3, and Q4.
differential amplifier.
differential.
Exactly. This is a differential amplifier. It provides some gain to the system, to the input signal. So if you have your input signal coming this way, this is input negative. This is input positive. You are or you are applying a some gain to the circuit, and this is your output. Okay, so the output, let's say star, it will be the gain of the differential amplifier. And of course, you are applying the output star to what? What is Q6, Shabab? What type of an amplifier is Q6?
Source.
Common source. So you have another stage. So let me call this one A1, and this is A2. So the gain of this op-amp will be A1 times A2. Okay. A1 is the gain of the differential amplifier. A2 is the gain of the common source, which is Q6. Tamam? Make sense? So this is nothing but an op-amp. So what do you think of the poles, the number of poles here? How many poles we have in the system? What do you think? In general, more than 3 poles, يا شباب? أعطونا إجابة يا شباب.
Maybe 5.
Maybe what?
5.
Yeah, the answer is yes. Yeah, we may have more than 3 poles. فالآن you have to be very, very careful. Because if you have more than 3 poles, we said, okay, the system, if you apply a negative feedback, you are trying, for example, this is an op-amp, صح? And by the way, this is an open loop op-amp. Still, it's not in a feedback connection. So we want, for example, to include to extend the bandwidth. So we want to have a negative feedback connection. But you need to be very, very careful before doing so. Because if you apply a feedback right away, the system may be unstable at some point لانه عندك number of poles maybe 3 or more صح يا شباب؟ وهذه الكونديشن اللي قلنا you have to be very careful if you have a number of poles, if you have 3 poles or more. So what we usually do, we usually introduce ايش الكونديشن حق الاستابيليتي يا شباب؟ عندنا قلنا single or double pole صح؟ يكون عندك single pole او 2 poles خلاص انت متاكد ان السيستم stable. يا شباب I'm talking now in high level thinking, it's not in the actual analysis. But we need to see how we can approach this, the problem and how we can solve it. فالآن عندك السيستم it has more than 3 poles فعندك متوقع أنت وعارف okay it may oscillate or it may be unstable at some point or for some frequencies. So what will be the solution for this one? What do you think if I can bring those 3 poles or reduce those 3 poles into one single pole? Can I do that? Or will that solve the problem? لما أجيب السيستم هو 3 poles وعنده احتمالية إنه يكون unstable أنا ضحكت على السيستم سويت تريك معين okay I bring those 3 poles into one single pole. كويس؟ متفقين معي إنه السيستم بيكون stable؟
Yes, I think it's going to be stable.
Okay, so now the dominant pole خلينا نسميها. So if you have, this is pole 1, pole 2, pole 3, okay? Let me draw it again in better shape. Pole 1, pole 2, and pole 3. Of course, minus 20. And I am drawing, sorry guys, I am drawing gain. This is first pole, this is second pole, and this is third pole. And I am considering 3 poles for the system. تمام؟ طبعا it can be more. يعني واحد من الشباب قال 5, it's okay يعني. But we are sure this is a system. This system can have more than 3 poles. And this one minus 40, and this one should be minus 60 dB. Okay? So the main idea here. خلوني أطلع من ال. I need to change the colors, but somehow. خلوني أسوي شير للسكرين بدل ال. How can I do this? Okay. في مشكلة عند شباب التول بار جاي مغطي على الصفحة اللي تحت. أحد يعطينا حل؟ التول بار اللي هنا مغطي على الباوربوينت. ما أنا قادر أشيله صراحة.
جربت تفتحه وتقفله؟
طيب, let me do this. Okay. And do this again. No, again, it is the same issue. طيب, I will keep using the red color. معلش يا شباب. Okay. No, I thought it's much better to use.
Doctor, is the concept of gathering the poles is like Tn and tau in and tau out we used before?
Yeah, the same. So, for example, you are finding FP1 to be the pole associated with this one, with this node here, صح؟ اللي هي البارازيتيك كاباسيترز الموجودة هنا مضروبة في الeffective resistance 1 over that. طبعا multiplied by 2 pi. Right? And let's say FP2 is the pole associated here with this this kind of node. The other one is the pole associated with V out and so on. طبعا after finding all parasitic capacitors. Okay? So these are the same poles that we were talking about before. طيب, so now I want to use Miller. طبعا احنا كنا نقول Miller is bad, is very bad for us, صح؟ دائما نقول very bad. بس اليوم بنستخدم Miller عشان يفيدنا. And this is how we do it. I mean, this is the engineering. Usually something looks bad, but we are trying to use it in our favor. Okay? فدائما نقلب الأمور بحيث أنها تكون بطريقة صحيحة. So what we can do, if someone شباب from you can suggest a way to introduce a new pole here. I want to introduce a new pole here, huh? So this is a new pole. Let me call it, this is PN. and that pole will what? Will take over all poles somehow. So the system will not see these three poles, sorry. يعني خلينا نقول overcome ال 3 poles. يعني كأني ايش حطيت الآن نيو بول والبول الجديدة غطت على البقية لأنه this is my dominant pole. Okay, my frequency is dominated or it is counted or it is estimated by FP new. صح يا شباب؟ فهذه العملية اللي أنا سويتها إني أضفت بول جديدة أصغر بكثير من الجميع، خلونا نقول 10 times or even more, maybe sometimes 100 times less than all poles. Looks fine. Can I do this? لما عملت الآن هل حولت السيستم من 3 poles إلى single pole؟ معناته حولته من unstable أو احتمالية unstable إلى stable؟
Yes.
ممتاز، يعني أنا ضحكت على السيستم صح؟ وضبطها بطريقة ممتازة. So let's now try to find a way to find FPN. What do you think يا شباب؟ How can a pole in a system? In general عندك سيستم بتحط بول فيه، ايش نسوي؟
Find the equivalent
البول بالعاده هو
capacitance.
associated with what؟ The resistor ولا capacitor ولا inductor؟
هذا كاباستر.
capacitor and inductor صح؟ اللي هم ال two passive elements اللي هم الكاباسيتر والinductor. So we can put some capacitor in the system, but then we need to have a large capacitor صح؟ لأنه you are pulling the pole now toward the left. يعني الآن تبغى مثلا خلينا نقول من أول كان عندك خلينا نقول 100 kilohertz. Now you want to have FPN to be 1 kilohertz or maybe less. Usually it is around 10 or even 5 hertz. But let's keep this in mind. Now we are dealing with a very low frequency. فنحتاج very large capacitor صح؟ How can we do a large capacitor؟ طبعا لاحظوا شباب من زمان كنا نقول ال large capacitors are undesirable في electronics in general and in particular in analog in IC design. So how can I find a large capacitor؟ أبى أحط capacitor وأبغى ال effective capacitance حقه large. إيش رأيكم؟
series capacitors.
series capacitor. طيب
added between 2 Miller node to
الله عليك ممتاز جدا. This is what we need to do. Exactly, this is what we need to do. حط الكاباسيتر between two nodes بينهم inverting gain على طول على الافكتيف كاباسيتر يكون عندك ايش؟ very large. multiply by the gain. لاحظوا انه من اول كنا نقول الله هذه مشكلة، الان we are using Miller somehow. So what we are doing here, I can go here. Can I do this يا شباب؟ Can I add a capacitor from my side this way and I name it مثلا خلينا نقول C or CF maybe. تمام؟ Can I do this? So what is the effective capacitor seen from this side? This is dotted, it means the effective one. طبعا it will split, ال CF will be split it into two capacitors صح؟ واحد منهم بالجراوند حق عفوا بالجيت حق ال Q6. The other one will be seen as اللي هو اللود output صح؟ So what will be the effective one here?
The one on the gate.
Don't you think it is 1 plus the gain multiplied by CF؟ طبعا الجين اللي هو A2 صح؟ فأنت أخذت كاباسيتر وكبرت الكاباسيتر you multiply by the gain okay and you introduce a new pole in the system and the system will be stable. تمام؟ So this is how we do it. شباب it's not usually I mean it's not always يعني all disadvantage in circuits disadvantage. Usually we can take it and we can use it somehow in our يعني way to improve the circuit. So this is an answer to this question. Is Miller capacitor always bad? The answer is no. In general, if you are considering a very high bandwidth, the answer is yes. But if you are considering a stability in the system, you may use Miller capacitor to stabilize the system. تمام؟ ايش المشكلة هنا يا شباب؟ ايش المشكلة الرئيسية اللي تشوفوها في عملية هذه اللعبة؟ احنا الآن حققنا الاستابيليتي في السيستم، بس ايش سوينا؟
We reduce the bandwidth.
Exactly, we reduce the bandwidth يعني بشكل مو طبيعي لأنه هذا أنت you are multiplying by 1 plus the gain and the gain are or is very very high usually. تمام. And by the way, this FPN usually around 5 to 10 hertz. تمام. So that's a lot of reduction. So we can get back to our يعني bandwidth by doing the negative feedback and then you multiply by the new bandwidth and you can get a few megahertz or so. واضح يا شباب? And by the way, this kind of process, this is what we call it frequency compensation in op-amp. Okay. طبعا we're not doing it in the op-amp as a block, يعني from outside. We are doing it internal circuit of the op-amp. تمام. طبعا ما في احد يجي يقول اوكي ابغى اشبك هنا كاباسيتور واسوي الاستابيليتي اوف ذا سيستم. No, we are not doing that لانه كل الاوبامز الموجوده الان بالسوق they have internal compensation capacitor inside. تمام. which is CF موجوده. اوكي يا شباب. Good. طيب let me ask you before leaving this topic here, what do you think of this circuit here? What is this circuit here? Or what does this circuit do? If this is Vn, what will be your V out?
It's a buffer.
It is a buffer, so V out will be what? Will be Vn, right? So it will be Vn, and your effective output impedance will be the small impedance seen from here, which is usually almost close to 0. Okay, so this is a buffer. Can I do the buffer here if you have this internal circuit? How can I make this one a buffer? يعني الآن الانترنال circuit الموجود الديفرنشال امبليفاير الموجود مع Q6 and this stuff. How can I make a buffer? Think? How can I do that, شباب? Very easy.
Common gate.
Can I do?
common brain.
Can I do
Common
this?
drain.
Maybe just connecting the V out to V negative, صح? And this is what I am doing here. لأنه الديفرنشال امبليفاير اللي هو Q1 وال Q2 عبارة عن input the stage of your differential amplifier. And what I just need to short the V output to V negative, and that's it. Okay. So if someone come and say, okay, what is I need to go to that slide. Okay. Other slide, please. Okay, perfect. So if someone give you this circuit, okay, and this is, of course, this is an NMOS differential amplifier. Okay, and say, okay, what is the feedback here? What is the feedback here? Let me call this one V input. By the way, do we have a feedback here?
No.
شورت اللهم سلك بين الاوتبوت والانبوت ما في.
طيب, okay. So this one, do you consider this short to be a feedback or no?
No.
So what do you think of this circuit? The buffer that I draw. So this is V out equals V in, of course, and this is V in. So do we have a feedback here?
Feedback beta equal 1.
Okay, beta equal 1. So what is the gain? It is A multiplied by 1, divided by 1 plus almost A. And of course, A usually is high. The open loop gain of the op-amp usually is a few thousands. So this one will be what? Almost
1.
Almost 1. So do we have a feedback ولا لا؟ عندك الجين صار reduction صح؟ في equal يا شباب عند واحد من الشباب. So this is still a feedback. والبيتا كم قيمتها يا شباب؟ البيتا هنا equals 1. And this is exactly the same here. This is a feedback system. You have data connect equals to 1. So what is the topology of this feedback? What do you think? What is the topology here?
Series shunt.
Series shunt, exactly. So we are doing it in series and the output is shunt. So at the end of the day, this is nothing but a buffer. So you are doing the buffer in the same way, but it is internal circuit. Okay. But someone will say, okay, I can add here a resistors, some voltage resistor, that's fine. But also we can short it and it will give you a buffer. Okay. If you add a resistor, of course, your beta will not be 1. It will be less than that. Okay, because you are applying voltage division here. Beta is you are doing buffer. Okay. Okay, Shabab. So
Okay.
let me now go to the other topic of today. Let me close this one. Have an issue with the... So I will stop sharing here and I will come on. Okay. بعض أوقات التقنية ما تخدمنا للأسف. الله المستعان. Keep and then save. Okay. Sorry, guys. Okay. Anyway, it looks like a... Yeah, the PowerPoint is frozen from my side. طيب ما في مشكلة ولا تزعل. قال لي errors. Do you still have the slides, Shabab? You can see the slides, no?
No, you can see it.
طيب Shabab, I need... no, this is a... I thought of restarting, but I will go off the session. So let me try something else. Perfect. ممتاز. Okay. So share the screen here. طيب, for our next topic in 303, we are doing الآن applications. Okay. So we will use, or we have 3 different applications. We have filters, and second we have oscillators, and then we'll cover the ADC اللي هو analog to digital converters, and very briefly by the end of the course. So we'll focus on the filters, how we can do filters, and then we'll go to the oscillators next, inshallah. So, طبعا of course we are targeting here active filters, because I think most of you already know at least the basic filters اللي هو passive filters. تمام؟ طبعا of course we'll go over and identify different filter types. I needed to know if I give you a transfer function, I need you to identify which type is this filter. If I give you a circuit, I need you to analyze the circuit and decide which type of filter is this, and so on. And then we'll study the design analysis of the first and the second order filters in general. And also the cascading, how we can get higher order filters, because at the end of the day you may need, for example, for your application to have a 3rd or 5th order of an active filter, so we can do cascade to get that high order. لأنه يا شباب, we will focus only on the first and the second. And if you know how to find the first order and the second order, you can cascade them to give you 3rd order. You can cascade them to give you 5th order, and so on. Okay. So we are dealing with the first order and the second order as a blocks, as like building blocks. Okay. طبعا the material of this topic is from chapter 11 of the textbook. طيب. So in general, Shabab, I think this is trivial for you. You know that we have a lot of types for filters, and we can categorize them based on the operation or the elements that are used. So if you are considering operation, we have, of course, low pass filter, we have high pass filter, band pass filter, stop band filter, all pass filter, and so on. Okay. طبعا I have question mark about all pass filter. إذا كان هو all pass filter, what is the main idea of using all pass filter? يعني إذا الجميع all pass إيش فائدة الباب؟ شيل الباب وخلاص. صح؟ That's the point. We'll talk about it later inshallah in details. طبعا the low pass filter, it's obvious. It passes low frequencies, stopping high frequencies, while the high pass filter does the opposite. The band pass filter, what do you think of band pass filter, Shabab?
It will pass only a certain range of frequency.
Exactly. So it will pass only certain frequencies. It will reject both in the low frequency and the high frequency. Okay. And it is the opposite with the stop band filter, where you stop, or sometimes they call it notch. So notch is a special case of the stop band. Stop band where you have a range of frequencies. So if you have this situation, okay, and this is the gain here, okay, so this is the gain, and this is A, and let's assume this is almost 0.001A, okay, which is very close to zero. Let's use the ideal case. معلش. The ideal case is to have it zero. يعني we need all frequencies to go down to zero, and this is F1, this is F2. So you are rejecting all frequencies inside F1 until F2. But if you have a filter that is only rejecting one single frequency, usually we call it notch filter. So for notch filter, it goes this way. It takes only one frequency out, then it goes again. So this is what? This is notch filter. Okay. And usually it is very commonly used اللي هو 60 Hz notch filter. ايش هو 60 Hz؟ 60 Hz عادة يجي من وين يا شباب؟ معروف الفريكونسي هذا، قد سمعتوا فيه صح؟
ال 50 وال 60 من الباور.
بالضبط ال 50 وال 60 جايه من الباور. طبعا احنا بالنسبه لنا احنا السعوديه 60 هرتز. فعندك ال 60 هرتز موجوده بالباور، اوكي، everywhere. But for very sensitive devices, مثلا خلونا نقول biomedical device where you have your frequency range of operation، مثلا الهارت ريت، الاوبريشن حق الهارت ريت تقريبا around 150 هرتز، تمام؟ So you don't want to 60 hertz to interfere with the frequencies or your signals coming from the heart rate monitor or system. تمام? So we usually apply a notch filter to take the 60 hertz out, and then we deal with our signals coming from that monitor or that device or so on. Okay, so this is very, very important. تمام? What else? Okay, so this is for the operation, when it comes to operation. But what about the elements? I mean, we have passive filters and we have active filters. انتوا شفتوا الباسيف من أول صح? So what is this one يا شباب? What do you think of this one? If this is V out, this is V in, and you have R and C. This is a passive filter, but which type? Is it low pass, high pass?
Low pass.
Low pass filter. What do you think يا شباب?
هاي باس.
لازم نتأكد انكم نبغى نثبت، نبغى نتأكد انها صح.
C is open.
هل كان يا شباب
في الهاي فريكونسي الكاباسيتور حيكون اوبن، فالفولتج خلاص يصير عندك في الاوتبوت.
بالهاي فريكونسي ايش راح يصير ايوه بالضبط.
ايوه العكس، انا عكست
بالضبط. فالهاي فريكونسي الكاباسيتور ايش راح يصير؟ يصير له شورت، فالفي اوت راح يصير له ايش؟ شورت، ما يكون والداي will be zero. At the low frequency خلونا نقول extreme zero، الكاباسيتور صار open، V out
فطلع
equals
عندنا
V
الأوت.
in. So we are expecting to see something like this. This is the transfer function or the plot. And this is nothing but a low pass filter. صح شباب? So usually when we do a test سريع, تمام, when I give you any circuit, just use these two extremes. And we did that in the frequency response. In the frequency response, we said, okay, شباب, when you test the behavior of the system, is it low pass, high pass, and so on, you may just use the frequency, zero frequency and high or infinite frequency, where f equals to 0 and f equals to infinity. And then you can draw the circuit. This is a sketch to give you the pattern here. Right, this is a passive filter. What about active filters? What is the difference between passive and active filters? If I do this, Shabab, if I go here, let me take this one off. You can go back and to the video if you want. And they will take the same filter, okay? But now I am adding an amplifier to that. Positive, negative. What, by the way, what is this one? What does this circuit do?
A buffer.
buffer. البفر عندنا حاجتين في البفر. الجين equals to 1 وحاجة ثانية ايش هي؟ الاوتبوت امبيدنس. الاوتبوت امبيدنس اللي جاي من هنا seen by the output. ليش سميناها بفر؟ لأنه يعزل الانبوت من الاوتبوت صح؟ يعزل الاوتبوت من from this node. Let's say Vx. So whatever the load connected to the V out, this is RL, will not affect Vx. And that's why we said this is a buffer. So we are buffering the output impedance or the output node. تمام? So we call this one active filters. Why, Shabab, we call it active filters? I think it's obvious. Why we are using it or you calling it? ايش؟
To use active component like
it is the case. We are using active element. So if you have any active element inside the filter, now you are turning the filter from passive filter to filters. And of course, you can see maybe an option here that in active filters, imagine Shabab, let me go to the passive one. Imagine if I want to have a second order filters. Can I cascade them and still have the same pattern أو same behavior؟ يعني cascading بحطهم بجنب بعض، بتعامل مع هذا one block and I want to repeat them many times, 7, 10, 8 times. Am I going to get the same يعني behavior here or something different?
Same.
لاحظوا شباب السؤال هذا يعتمد على الeffective resistance seen by the V out. What is the effective resistance seen by the V out? Is it infinity from here or some impedance?
لا some impedance فعشان كذا ما حيكون لو
كل
ما زاد
في الحسبة right نعم. It will affect your transfer function
فما حيعطينا ال desired output.
Yes, exactly. While in active filters, what is the effective impedance seen from this side?
Infinity.
Exactly. So you are dealing with this block alone. تمام كأنك تحط بلوك وتحط بلوك ثاني وتحط بلوك ثالثة خلاص كل واحد ما يشوف الثاني. So each block will give you the desired output somehow. And this is the beauty of active filters. تمام. Second, طبعا in the other way you are minimizing the output impedance خلينا نقول effect or how you can load the other filter. The second advantage here, can I do this يا شباب? This is my passive filter. And by the way, what is the gain here? I have more than V input, passive element. Let me go back to the same filter. This one here. Can I have more than V input? يعني can I have a gain in the circuit?
لا البيست كيس نفسه ما حيكون.
Exactly, the best case where you have a zero frequency, V input equals to V output. فعندك الجين هو عبارة عن 1 وهذا في أفضل حالاته. It will be less than that for sure. So there is no gain in the passive element. I mean using the capacitors. طبعا واحد يجي يقول لي علشان الإندكتور. This is a different story, but let's focus on the capacitor here. And even with the inductor, you cannot get more than V input unless you have a diode or other switching element. But for now, let's focus on the RC filters. So we don't have gain here. What about this circuit here? can I change the buffer to R1 and R2? What do you think يا شباب? Can I do this?
يصير
Yes.
عندنا gain.
Okay. Input impedance still infinity. We are okay. And I am adding what? Gain to the filter. So I'm not only filtering, I am filtering and amplifying at the same time. قلنا لكم احنا engineers ما نخلي احد لوحده. Right? So we are exploiting الأوب أمب. خلاص ما دامت الأوب أمب موجود وبفر ليش ما اخليه يشتغل زيادة يعني؟ خليه يعمل لي amplifier كمان. Okay? So that's the beauty of active filters. It provides gain to the filters. But what is the disadvantage of active compared to passive filter? What do you think? الآن الاكتف فلتر يعطيك gain وعندك الامبيدنس ما له effect يعني kind of you can do cascading بكل أريحية. But what about the disadvantage? If this is the case خلاص let's use active filters دائما وأبدا. What do you think of disadvantage شباب?
Maybe the power that we use.
Exactly. الآن عندك active filter. إيش معنى active؟ دائما active. There's no free يعني free lunch here. You need to provide some power. So the power consumption here will be an issue, right? So you need to provide some power to get the gain or to get the input impedance, impedance, effective impedance infinity, and doing the cascade. So you can't do a trade-off here. طبعا if you are doing a high order filters, this is a good option. But then you need to make sure you are meeting the power issue here. Okay, clear يا شباب? I think I will, let me see the other slide. Yeah, I will, this is the transfer function in general. We'll come to that inshallah next, but I mean, you know what, Shabab, we have a magnitude and the phase. We can decide on the magnitude and the phase of the transfer function, right? And usually, and of course, sometimes, Shabab, we are using attenuation instead of gain, okay? The gain is what? What is the gain? V out over Vn. In general, huh? This is V out over Vn. Attenuation, still the same, V out over Vn. So what is the point here? What is the difference, Shabab, between attenuation and gain? From the mathematics point of view, they are the same. V output over V input. والاتنويشن هو V output على ال V input. طيب ايش الفرق بينهم؟ خلونا نرجع من المعنى اللغوي هنا. الجين it means ايش؟ more than one. Attenuation less than one. تمام؟ Or not even less than one. Less than the gain that is intended by the desired خلينا نقول specific اللي هو الابلكيشن. خلينا نقول الجين عندك 100 dB. Okay? If this is the gain 100 dB, then you have some roll off here, right? So that one will give you مثلا خلينا نقول at this point you are getting around 80 dB of gain. So that's the same thing. The signal is attenuated. Instead of having 100 dB gain, now it has 80 dB gain. صح? But at the end of the day, you are measuring V output over V input. تمام? Okay? But it doesn't mean that usually it is less than one. I mean, it can be one or less than one or even more than one if you are targeting a specific frequency. But at the end of the day, make sure, Shabab, you know that the gain and the attenuation are the same from the mathematics point of view, and they are V output over V input. Okay, I think I will leave you here. I'll stop here, inshallah. We'll continue on Sunday. Inshallah, weekend مبارك وطيب ومرح إن شاء الله.